matrices. We are going to prove 7 marks questions here. Important 7 marks in the case of IPE. You have to learn all these things, right once. Look here, the question is, prove that determinant of this is equal to a plus b plus c whole cube. Let us take LHS. Look here, let us take LHS. A minus b minus c. 2a, 2a, 2b, last term is 2b, middle term is b minus c, 2c, 2c, c minus c minus. If you add these terms, it becomes 5a minus b minus columns. If you add like this, look here, what I write is R1 tends to, R1 is changed as R1 plus R2 plus R3. What lies in R1 in first element? A minus b minus c. So when you add 2b, it becomes a plus b. When you add 2c, it becomes a plus b plus. So this LHS I can write it as like this. This LHS I can write it as like this. What I can write is, this LHS I can write like this. That is, when you add, you'll get the a plus b plus c, and when you add like this, it becomes b plus c plus a. That is a plus b plus c. Again, when you add these three terms, you will get the a plus b plus c. Right? Next row is common here. It is 2b. Here 2b, b minus c minus c. Next it is 2c, 2c, c minus a minus b. Now, taking a plus b plus c common. Take a plus b plus c common. So that is what you can write. When you take a plus b plus c common, there is an extra step here. When you take a plus b plus c common, you will get the a plus b plus c into a plus b plus c into 1 element. Here it is 1, there is 1, there is 1, and then 2b, b minus c, 2b, and then 2c, 2c, c minus a minus b. Okay, so I can write next step. What is the next step? All the elements in the first one are 1, isn't it? So next step, I'll write like this. What we can write? Look here. The next step, I want to make this element 0. So what I can write is, first one is C2 tends to, this element must be operated on this. So C2 tends to C2 minus C1, and C3 tends to C3 minus C1. I operated C2 on C1 and C3 on C1. Now, first column is not unaltered. Okay, so there is 1, there is 2b, there is 2c, and then 1 minus 1. 1 minus 1 is 0. And then b minus c minus 2b is minus b. b minus 2b is minus b minus c, right? And then last term 2c minus 2c is 0. Again 0, 0. c minus 2c is minus c minus a minus b. So this is equal to a plus b plus c into, isn't it? Are you clear? Yeah, up to here. Alright, next step. Next step, what you have to say is, take a plus b plus c, taking a plus b plus c from second column, a plus b plus c in third column, or else minus of a plus b plus c in second column, minus of a plus b plus c in third column, so that minus of minus becomes plus. This becomes a plus b plus c. If we take this here, minus a plus b plus c minus, or else directly you can find the that value, since it's an upper triangular. There is a triangular matrix. Its determinant is determinant. I can write the determinant directly as like this. Directly you can write the determinant value as 1 into 1 into these two things. When you multiply, you will get the a plus b plus c whole square minus 0. Everything is 0. So answer is a plus b plus c whole cube. A plus b plus c whole cube. Look at the problem now. Let us take LHS. And there is a b plus c plus a plus b. Then c plus c, a plus b, b plus c, a plus b, b plus c, c plus c. Okay. Right, let us add all these things. What will get? R1 tends to R1 plus R2 plus R3. So that the first row becomes row. We add all these rows. Then we get the 2 times of a plus b plus c. Isn't it? 2c, 2b, 2a. Similarly, a plus 2 times of a plus b plus c. And then 2 times of a plus b plus c. Remaining is c plus a plus b, b plus c. And then a plus b, b plus c, c plus c. From here, I can take 2 common. 2 into a plus b plus c, a plus b plus c, a plus b plus c, c plus c, a plus b, b plus c. Then a plus b, b plus c, c plus c. Next step, look here. I try to write like this. Okay. This without operation, I have taken 2 common. According to property, if k is multiplied to a row, k can be taken common. Since we have to prove that determinant of a, b, c, b, c is c, a, b, I haven't taken a plus b plus c as common. Okay. So this 2 into. What is if I write R1 tends to R1 minus or else R3 tends to R3 minus R1. Right, R3 tends to R3 minus R1. So a plus b plus c here. This is a plus b plus c. Then a plus b plus c. First row is same. I take R2 also here. R2 tends to R2 minus R1. R3 and R2 are changed. R3 how it changed? R2 how it changed? R2 minus R1 means c plus a minus b is minus b. Then a plus b minus this is minus c. Similarly, minus c, minus a, minus b. If you take the minus in second row and the third row, minus in second row and third row, what will you get? Else 2 into, look here, R1 tends to plus R2 plus R3. What is the value you get? You add all these things, A, B, C, then minus B, minus C, minus C, minus A, A, B. If you take the minus common from row 2, you get minus. Again column row R3 minus, you will get the positive 2 into determinant of ABC, BCA, CA. And second, prove that determinant of A plus B plus 2C, A, B, again C, C. Look here, the terms. We must have an idea that when you add all these terms like this, you get 2A plus 2B plus 2C. This 2B, 2C, 2B, 2A. Right? When you add like this, you'll get 2A plus 2B plus 2C. When you add like this, you'll get A plus B plus 4C. A plus 4A plus B plus C. This is CA plus C plus 4B. So I decide like this. C1 tends to C1 plus C2 plus C3. I add all the columns. So that this becomes 2 times of A plus B plus C There is 2 times of A plus B plus C. There is 2 times of A plus B plus. Next one is A, B, B plus C plus 2A, then B, A, C plus A plus 2. Okay, right. Next, take 2 common. Write the step here. Write 2 times of A plus B plus C common. What will be there in the determinant now? 1, 1, 1. A, B, B plus C plus 2A, B, and then A, C plus A plus 2A. You can do this. When you want like this, you must subtract C2 from C1 and C3 from C1. The second row, third row elements. 1 is there in the initial stage, so I can write it as what are the changes means R2 I will change as R2 minus R1. I operated R2 on R1. Similarly, R3 on R1. R3 turns to R3 minus R1. So there is no change in first row. There is 1 AB. Second row. There is 2 times of A plus B plus C. Sorry, 2 times of A plus B plus C. And then 1 minus 1 0. B plus C plus 2A minus A is B plus C plus A. And then B minus B becomes 0. There is 0. A minus A is 0. C plus A plus 2B minus B is B. Is it clear? Right. Next up, I can write like this. Next up, I can write like this. There is 2 times of A plus B plus C into. Instead of writing, since triangular matrix is formed, determinant is product of principal diagonal elements. So 1 into B plus C plus A into C plus A plus B. So we can write it as 2 times of A plus B plus C whole cube. Already what? This 2 becomes whole cube. There is RHS. Okay. Let us solve this an important problem, an important 7 mass problem. Very, very important. Many times it's given. Let us take x is equal to the first determinant value, that is ABC, BCA, CAB, then whole square. So I can write it as, I can take the determinant value, det A whole square. I write in the value of det A, and then I square it. Right? So what is the determinant value? A into BC minus A square, and then minus B into B square minus AC, and then plus C into there is AB minus C square, AB minus C square. Right. Next, multiply. This becomes ABC minus A cube minus B cubed minus ABC. No, it's plus ABC. There is ABC minus C cube whole square. Take minus common. Minus of A cube plus B cube plus C cube. A cube, B cube, C cube, minus common. Plus 3ABC is there, minus is taken common, so there is minus 3ABC. So whole square is there. So I can write as A cubed plus B cubed plus C cubed minus 3ABC whole square. Minus A whole square is A square. So I consider this as Y. There is Y. Right? Next, we'll go from the again. Take x value. Take x value so that you can see what is x. X I can take again as ABC, ABC, BCA, CAB. Det A whole square, I can write it as det A whole square, I can write it as det A into det A. Det of ABC, BCA, CAB. Det of AB is det A into det B, det A into det B. Here is ABC, BCA, CAB. Now, interchange these two rows. Interchange these two rows. In second, I interchange R2 and R3. What will get? You will get the minus there is det of ABC, BCA, CAB. If you interchange any two rows, sign of the determinant changes. Sign of the determinant changes. So it is a plus determinant, so it is minus of ABC. BCA, CAB is interchanged, so CAB, BCA. Okay? Alright. Next, we'll go for next level. Then multiply minus to either of the rows. Since these two rows are interchanged, I multiply this minus to the first row. So what happens? This becomes ABC, BCA, CAB into minus A, minus B, minus C, CAB, BCA. Okay, is it clear? No, AB is there. AB is there, multiply AB. Det A into det B is det AB. Since determinant of AB is det A into det B. If det A into det B is observed, it can be written as det of AB. So I multiply these two things. Determinant of AB. So multiply first row with the first column. There is minus A square plus BC plus BC. Next row. Minus AB and then plus AB plus C square. And then minus AC plus B square plus AC. So there is the determinant. Next, I will go for second row. BCA is multiplied with minus ACB. Minus AB and then plus C square plus AB. Right. And the next minus B square plus AC plus AC. And then minus BC plus BC plus A square. Next row. Third row with the first column. So I will get the minus AC and then plus AC plus B square. And then next element is minus BC plus A square plus BC. And then last column is minus C square plus AB plus A. So this can be written as determinant of 2BC minus A square. AB gets cancelled here. Here AC gets cancelled. Here BC gets cancelled. Here AB gets cancelled. Here AC gets cancelled. Here BC gets cancelled. So here it is C square. Here it is B square. And then next element is C square. Next is 2AC minus B square, and then A square, and then B square, A square, and then 2AB minus C square. I consider this as Z. Since x is equal to y and x is equal to z, this implies I can conclude it as x is equal to y equal to z, or x is equal to z is equal to y. Look here, move to the first one. Initially the problem is like this: ABC, BC, CAB whole square. I have taken this as x, and I put this as y. This as y. Next again taken x, and delta square is taken as delta A into delta B, delta A into delta B. Delta A square can be written as delta of A into A, det A into det A, that is. Det A, one of the det A, in one of the det A, two rows are interchanged, so that I get minus. If I multiply minus to any of the rows, so I multiplied it into first row. So now det of det A into det B is nothing but det AB. So det A into det B is nothing but det AB. When I multiplied AB, I got the value of z like this. So x is equal to y and y is equal to z. Therefore x is equal to z is equal to y. And very important problem you have to learn.
So important problem, important 7 marks, given many times, very important. Let us take this value. I consider b is equal to minus a. b equal to minus a means a plus b is equal to 0. I consider b as minus a. I take LHS. Take LHS. So b as minus a. Consider this determinant. What happens? This is minus 2a, 0, c plus a. And then again, a plus b becomes 0, minus 2b becomes b is equal to minus a. So plus a, plus 2a. And then b is minus a. So I can write it as minus a plus c. And then c plus a. And then c minus a. And then minus 2c. Now, add these two rows, what you'll get? Subtract these two rows. I write it like this: R2 tends to R2 minus R1, R2 minus R1, and R3 tends to, and R3 tends to R3 plus R1. Let's look here: minus 2a, 0, c plus a. First row there is no change. Second row I have to subtract from this. 0 minus of minus 2a is 2a. 2a minus 0 is 2a. Then minus a minus c plus c minus c gets cancelled. Minus a becomes minus 2a. Right. R3 tends to R3 plus R1. When you add these two elements, c plus a minus 2a is c minus a. And then c minus a plus 0 is c minus a. And then minus 2c plus c is minus c plus a. There is minus c plus a. Now look here. Look here. I can write like this. From second row I take 2a common, and third row I take c minus a common. What happens? There is minus 2a, 0, c plus a, and then 1, 1, minus 1, and last row becomes c minus a taken common, 1, 1, minus 1. Since these two rows are identical, its determinant is 0. Its determinant is 0. So what you can write here? According to a property, since I considered b is equal to minus a plus b made this determinant 0. Therefore, a plus b for a plus b is equal to 0. This determinant is 0. This determinant is 0. Which means a plus b is one of the factor of the determinant according to a property. Okay. Similarly, we can prove B plus C and C plus A are also the factors. Okay, so means if you consider B plus C is equal to 0, or substitute C is equal to minus B, or C is equal to minus A, again we will get the determinant as 0. Again we will get a determinant as 0. So I can write now the determinant as like this. So this determinant will have factors. This determinant will have factors as A plus B, B plus C, and C plus A. There is a rhythmic order, no? There is a rhythmic order as minus 2A, minus 2A, minus 2B, minus 2C. Next, A plus B here, A plus B here, again A plus B here. Okay, and then C plus A. First row, third column element, third row, first column element is C plus A. Here it is B plus C, here it is B plus C. So when you consider the A plus B is equal to 0, this determinant becomes 0. When you consider C plus A 0, again it becomes 0. B plus C is equal to 0, again this determinant is 0. Therefore, I can write A plus B, B plus C, C plus C are the factors. There may be a constant lies in it. I consider it as K. We have to find the K value of K in this. Generally, as that of objective, here also we consider the values of ABC. We consider the values of ABC as A is equal to 0, B is equal to 1, C is equal to 2. Substitute, find the value of K, then that is the end of the problem. So when you substitute A is equal to 0, it becomes 0, A plus B is 1, C plus A is 2, and then A plus B is 1, B plus minus 2B is minus 2, and then B plus C is 3, and then C plus A is 2, B plus C is 3, and minus 2C is minus 4 is equal to K times of A plus B, B plus C, C plus A. Okay, then write the determinant value 0, minus 1 into minus 4 minus 6, minus 4 minus 6, and then plus 2 into 3 minus 3 minus of minus 4 is 3 plus 4 is equal to 6K. So this implies 6K is equal to 10 plus this 7 to 14. So 14 plus 10 is 24. So K is equal to 4. Substitute here. We'll get the determinant is equal to 4 times of A plus B, B plus C, C plus A. That's the end of the problem, which is an important problem. So I can conclude here as therefore a determinant of minus 2A, and then A plus B, C plus A, and then A plus B, minus 2B, B plus C, and then C plus A, B plus C, minus 2C is equal to 4 times of A plus B, B plus C, C plus A. So try once. Here the only thing is when x is equal to A is substituted, if the determinant is 0, then x minus A is the factor of the determinant. That's the principle used here. Okay.